After welded joint, the next joint that we are going to see today is the screw joint. Already we know what are the different types of screw and what is the use of the screw joint. We are going to focus on design of the screw. As we know, a screw thread is formed by fitting continuously helical groove on the cylindrical surface. So this helical groove in connection with the matching threads which are formed in the nut, we can screw up two different objects together. If that screw is only a single threaded, then it is called single start screw. If second thread is cut in the space between the groove of the first, then it is called double threaded. If it is there are three or more, then it is called multi-start. If you just look at this picture, you will find that here the nominal diameter, the major diameter, the pitch diameter, the minor diameter, that already we know. So these are the diameter. We know that there is a pitch. So pitch of that screw is also we know. We know that different other nomenclatures like helix angle, depth of the thread, root, crest, etc. So that already we have studied in our machine design, machine drawing. Okay. So as far as syllabus is concerned, we are interested in design procedure. So next to that, as far as types of screws are concerned, these are some standard types like American National Standard Thread, Unified Standard Thread, or British Standard Whitworth, or British Association Thread. All in all these different types of thread, the important thing is including angle. For standard thread, including angle between that thread is 60. So if it is 55 or if it is 47, then British had given these two types. In addition to these screw, we know that there are power screw that already we have studied. The square thread, acme thread, or knuckle thread, or buttress thread, trapezoidal thread. These are some additional threads. As far as question is concerned in our exam, we may have one simple question like this: what are the advantages and disadvantages? So these are the advantages or disadvantages of screw joint over our welded or riveted joint. So what are those advantages? Screw joints are highly reliable in operation. Screw joints are convenient to assemble and disassemble. This is most important advantage. Welded joint, once it is welded, it becomes permanent joint. But as far as screw joints are concerned, screw joint can be conveniently assembled or disassembled. Wide range of screw joint may be adopted for various operations. So, for the mass production, screw joints are cheap to produce. That is the main advantage. But as we know, one more advantage of the screw joint we can put here is we can join two different materials together. So in case of welded joint, we cannot weld plastic with steel, but it can be possible by using screw joint. We can assemble two plate. One is of steel and another is of plastic. So that is one of our advantage. Basically, in the screw joint, we have to drill a hole. So when we drill a hole inside any sheet or inside any material, and if that material is subjected to forces, obviously there is a possibility of stress concentration. So that is the main disadvantage of screw joint. The screw joint is having stress concentration. That is the main important disadvantage. In addition to that, the screw joints are not that much helpful if there is a heavy shocks and heavy uh, impact loads. So that may get loosened. So that's why we need one more locking nut and other things. Okay. So these are the advantages and disadvantages. So in our exam, there may be chances that you may ask write some advantage or disadvantage. So at least you must able to write four advantages and one or two disadvantages for the 4 marks. Okay. So next to that, when we think about the design, stresses in the screw fastener. So just look at here. Here, so first thing we must consider about the initial stresses due to screwing up. As we know, in our screw, in our screw fastener, we are having mainly two different ways by which the screw are stressed. So first is initial stresses due to screwing up. As there is a nut and bolt, and nut and bolt are tightened by some spanner or some screwdriver. So because of tightening only, there is a stresses. So these stresses we can say that initial stresses. The second stress, that is because of external forces. So that is because of external forces. So when that screw joint is subjected to some external forces, so that also creates a stresses. And obviously, the third is combination of screwing up and external stresses. That is the third stress. So we are going to consider these three stresses here for our design process. Actually, uh, as far as syllabus is concerned, and as far as last few question paper, if you see, you will not find any question related directly based on this, but application of these different uh, design equations, and based on that there are some questions. Okay. So nobody is going to ask what are the different stresses, initial stresses or stresses due to external forces. So you write all these things. Such type of question is not asked. But the problem based on this is asked for formula. Okay, one by one we will take stresses in the screw fastener. First we will take the stresses, initial stresses due to screwing up. In that, the first is the initial tensile stress due to screwing up. Okay, so tensile stress due to screwing up, that is the first stress. As we know, these screw are having variety of applications. For example, there is a cover of our any fluid type joint, like the cover of a steam pipeline, or cover of a boiler, or a cover on oil flow pipelines. So in that, there should not be any leakage. There should not be leakage. So in such cases, you have to tight that screw in such a fashion that there should be fluid type joint. So first screwing up stresses, initial stresses is based on fluid tight joint. So again, there is a limitation. If you take the bolt size less than M16, M16 means major diameter is less than 16 mm. So bolt, such type of bolt, if you use for tightening purpose, that screw may get filled in torsion. because of size is very very small. So if you try to type that, that screw will get failed. Okay, so that's why this fluid tight joint required bolt height more than M60. So when we think about screwing up, the fluid tight joint initial tension can be 2840 times D0. So that much amount of initial tension is possible because of screwing up fluid tight joint. So this is the relationship which comes from experimentation and empirical formulation. So initial tension because of this fluid tight uh, joint on the bolt is 2840 D0. So this much amount of tension we have to consider when we think about fluid tight. If there is a non-fluid tight joint, other than, so you must consider initial tension equal to 1420 times D0. D0 is nominal or outside diameter of the bolt. So tensile stress, when we think about the tensile stress on this screwing up of the screw, then that can be tensile stress is equal to that uh, initial tension Pi divided by area. Area is obviously pi by 4 d square. So this is the first stress that we have to consider in the screwing up. In the screwing up, we have to consider fluid tight and non-fluid tight joint. Okay. Now, if you go further, second type of stress is the stress because of shear stress, because of the shearing action. So this screw is tightened by some span. Spanner is going to rotate that. That means there is a torque. If there is a torque, obviously there is a torsional shear stress. So torsional shear stress because of torque, that we can write like this by this formula. Torsional shear stress is equal to T divided by pi by 60 BC cube. If this particular force is going to shear out the thread, so there is an initial shear stress across the thread. So that thread area that can be we can find by pi d0 t into n. So pi d0 is the perimeter of that shear area into t is the thickness, total thickness into n is number of threads. So in our previous section also, in our power screw already we have seen this type of uh, formula related to shear stress across the thread. Now if the screw is having large height, then there is a possibility that there is a bending stress. So in that bending stress, this height is important. H. Height means how much amount of gap is there between your screw and the bolt. If it is more, then there is a possibility that bolt may bend while screwing. Okay. So there is a crushing stress also. So crushing stress due to screwing up can be have area pi by d0 square minus di square. So already this formula also we have seen in our power. So this is crushing stress. So all these type of stresses that can be possible while screwing up. So same thing. This is a repetition of different formulas that already we have studied in our power. That's why I have written only the formulation. So only because of screwing up, because of spanner, this much kind of stresses are there. So in addition to screwing up, there are stresses. There are stresses because of external forces also. So because of external force, what are the stresses? So there is a tensile stress. The tensile stress that we can find by using our simple formula force divided by area. There is a direct shear stress on the bolt. If there is a force which is perpendicular to the axis of the bolt, then there is a direct shear stress on the bolt because of external force. Just like in our coupling, the bolt which are used in coupling is subjected to direct shear stress. So that also we can find. If I combine these two, then we know that the tensile stress and shear stress that can be combined by using this combined stress equation. So here we have seen different kind of stress equation which are used for tightening or for screwing up and because of external force. Here these are the different type of failure, possible failure in our board. As far as question paper is concerned, we have few questions based on this in which only we have to use one or two formula. Okay, we'll take few numerical, and in that you will find that this much different kinds of formulas are not necessary, because whatever question which are asked in our exam, that questions are basically based on simple formula. Okay. So this is stresses due to external forces. Now there is a one more concept which is generally asked for 2 to 4 marks. So what is meant by bolt of uniform strength? In our bolt, as we know, bolts are having threaded part. The threaded part are having up and down or variety of diameters, outside diameter, inside diameter, uh, root, face, flank. So because of that, there is a chances of stress concentration when it is subjected to variety of simple or impact loading or variable loading. There is a there is stress concentration in our bolt, and that stress concentration is mainly on the threaded part. So when the bolt is subjected to different kind of loading, this threaded part is mainly paid. So to strengthen that, or there should not be any failure, we have to shift stresses on the other part. So how it can be possible? It can be possible by using two methods. So that is called as a bolt of uniform strength. We have to keep that bolt with uniform strength in all over its shank and threaded part. So how it can be possible? We can do very simple way. Now let us look at this second picture. In that, you'll find that if I keep diameter of our screw somewhat lesser than the previous one. Here the diameter of this shank and the threaded part is same. Because of that, here there is a stress concentration, because here the BC will come. Here there is a core diameter. Because of core diameter, the diameter of shank and diameter of core diameter is this. But if you just see here, if you turn out, if you turn out that shank part of the body of that screw, with somewhat lesser diameter. Then here this diameter and the core diameter becomes equal. The core diameter becomes equal. So it is having same diameter, and because of that uniform stresses or uniform stress lines are there. So possibility of stress concentration is lesser. So this is first method by which we can reduce the stress concentration inside the bolt, or we can say that we can have a uniform strain bolt. Okay. The second method is, you can see here in the second method, reduce the strength of shank by drilling one hole. You can see here there is a dotted line. The dotted line indicates we are going to drill the hole inside the shank. Because of this hole, the strength of this part and the strength of our threaded part becomes equal, and because of that, the stresses are uniformly distributed, and the shank part and the threaded part will absorb same amount of energy. So this relieves some stresses on the threaded part. By this way, we can increase the shock absorbing capacity of the build, and the modulus of resilience. The resilience means to take shock and to absorb the shock and to absorb variable loading. That capacity is going to increase. So that's why it is called force of uniform strength. So in this, if the bolts of uniform strength is asked in our exam, it is expected that you should write about the stress concentration in the bolt by drawing this first figure A, and after that you must draw these two figures as a solution how to reduce the stress concentration when the bolt is subjected to large amount of forces, variable forces, or the impact forces. So we are making our simple bolt by converting it into bolt of uniform strength. So that is the concept. Okay. In our this screw joint, we are having some applications of this screwed or bolted joint. So bolted joint under eccentric loading. As I told you, the problems which are asked, the numericals which are asked in our exam is not based on the criteria which are used for screwing up or which are for the external process, but the problems are asked on this eccentric load. So as per applications are concerned, you can see the voltage joints are used to support the load by different way. These voltage joints are having basically three different possibilities of application. So when the bolts are, you can see one end for the figure one. In the figure one, the bolts are parallel to the axis of the load. If this is the load, here the load W load is there, and here one and two are the axis of our bolt. When the axis of the load is parallel to the axis of the bolt, this is one condition. In the second figure, you'll find that the load axis is exactly perpendicular. So this is the axis of load, and here you will find the axis of our bolts. The axis of bolt is perpendicular to the axis of our load. Okay. The third case that we are going to see is the load, the load axis is not parallel, not perpendicular, but in the plane of containing bolts. So here we will find that this is the direction of our load, and the bolts are here. The bolts are having axes which are in plane with the our plate. So the bolt axis is perpendicular to the screen, or perpendicular to the our board. So this is third condition. Here we are going to see detail about the numerical which are based on this. When we go for the numerical, so this is introduction of all this voltage and fluid. When we say about when we think about numerical, in that again I will explain you one by one all the different uh, failure criteria as well as the formulation that we have studied in our introduction lecture. In the introduction lecture, just we have seen different formulas. Now, how to use that formula, how that these different kinds of applications, and how we can find the diameter of the bolt, that we'll see in the detail. So today we'll stop here, and this is our introduction lecture on this.